Okay, so this 95 degrees is a central angle intercepting A, so A is also 95 degrees. 95 degrees and B together are supplementary. They add up to 180 degrees. So B must be 180 minus 95, which is 85 degrees. Okay, and then C, the intercepted arc, is this section, which we already know is 95 degrees. And I also know that the angle, the inscribed angle is half of its intercepted arc. So C is half of the intercepted arc of 95 degrees, which is 47.5 degrees. Okay, over here, these two angles are vertical, so this is 40 degrees. Okay, so using this central angle, vertex at the center, I know that if this is 40, the intercepted arc is also 40 degrees. And then using this 65 degree central angle means that this section, the intercepted arc, is also 65 degrees. Okay, so now what did they actually ask us for? They asked us for major arc EAC. So starting at E, going to A, and ending at C. Well, that's the rest of the circle besides what we already did. So we know a full circle is 360 degrees, so we take away 40 degrees, and we take away 65 degrees, and what's left over is 255 degrees. Okay, AB is a tangent. Well, let's see. X is a central angle, which intercepts a 120 degree arc, so X is also 120 degrees. So this unmarked angle down here also intercepts the 120 degree arc, but I know that inscribed angles are only half their intercepted arc. So half of 120 means that this angle over here is 60. Okay, and then I know that a straight line adds up to 180, so that must mean that Y is also 60. Okay, so I can see that like these parts are evenly spaced because their angles are the same. So this is 120, 360 minus 120 means there's 240 degrees left over in the circle. And then if we split it up evenly, each piece is 120. All right. So for this one, we see two chords crossing in a perpendicular bisector. So we know that, bisector means the two pieces are equal. So if this is 15, this is also 15. And then the other property we know is that when two chords intersect, the product of their pieces is equal. So one tricky thing is we need to extend this chord to the other side. Okay, so because the chord goes all the way through the circle, it's not just a radius. Okay, so, well, what's the diameter of the circle? Well, no, let's not do that yet. So we know our radius is 16.7. So focusing on these two pieces, together they form to be a radius. All right, so if I call this section X, well, the whole thing's 16.7. So if I take away X, that leaves this piece. So this little section is called 16.7 minus X. Okay, and then I know that this section is a radius just like this. So this distance is also 16.7. Okay, but I want to know this whole distance, not the two individual parts. So 16.7 plus 16.7 minus x becomes 33.4 minus x. Okay, so this whole distance in red is 33.4 minus x. So now we can apply the property that when two chords intersect, the product of the pieces is equal. So for this chord, we have 15 times 15. And for the other chord, we have x times 33.4 minus x. Okay, so let's get everything to the same side. Okay, so from here you could complete the square, or you could just use the quadratic formula. So I'll just say that this equals about 9.36. And again, you can solve this quadratic using the quadratic formula. Okay, so let's see. A intercepts this arc. So if the arc is 100, the inscribed angle is half of that, so 50 degrees. B, well, no, let's do C first. C intercepts this arc. So half of 140 degrees is 70 degrees. Okay, so now I use the fact that A, B, and C are in a triangle, right? 50 degrees plus 70 degrees plus B equals 180. Okay, so B is 60 degrees. Okay, AB and AC are tangents. Well, we've got a quadrilateral here, and we know that the circumscribed angle plus the central angle equals 180. Okay, so x is simply 140 degrees. AD is a tangent, so that means that this is 90. AC is a diameter, all right. Measure of angle A, that's the tangent. Measure of arc AB. Well, arc AB gets intercepted by angle ACD. So using this triangle, 90 plus 54 plus angle C equals 180. Okay, so you solve that to get that. Angle C must be 36 degrees. And we know that an inscribed angle is half of the intercepted arc. So if I know the angle, I double it. So 36 times 2 would be 72 degrees for arc AB. Okay, and then lastly, measure of arc CB. Well, because AC is a diameter, I know that combined this arc takes up half the circle, or 180 degrees. And I already used up 72 degrees over here. So that leaves 108 degrees for this arc. Okay, so let's see, we got a triangle here. So 80 plus 70 is 150, and that leaves 30 degrees for angle D. And then this inscribed angle intercepts arc AB, and I know the intercepted arc is double the inscribed angle. Okay, so what else do they ask for? AD. So arc AD gets intercepted by angle B, which is 70 degrees, so double that is 140 degrees. Okay, and then major arc DAB, well, we've already got the two pieces, so we just do 140 plus 60. Okay, so here we've got two intersecting chords, so we know their products are equal. So 7 times 12 equals 14 times x. X is 6. Over here we've got an inscribed quadrilateral. All four vertices are on the circle. So the property here is that opposite angles add up to 180. And then 80 and the x are opposites. Okay, problem 11. We see right here that the radius of this circle is 9.7. So combined, this distance is also 9.7. And then this distance is composed of a 5.1 plus an x. So simply subtract 5.1 from both sides, and we get that x would be 4.6. 12, R and S are both tangents. Okay, we're asked about W, which is an arc length, and this arc length gets intercepted by this central angle. So to find the central angle, we can use the fact that a central angle plus the circumscribed angle equals 180. Okay, so I'll just call this x for now. X plus 54 degrees equals 180 degrees. Oops. Okay, and then now that I know the central angle is equal in measure to its intercepted arc. So W is also 126 degrees. Okay, 13 we don't know how to do, right? We don't know how to deal with this situation where we have lines going outside that are not tangent. Same thing with 14. 15, okay, ED and EC are tangent. Okay, what is the measure of DC? Well, this whole circle is 360. The rest of it is 246. So how much is left over for DC? Oops. Okay, and they also ask about measure of angle DEC. Well, DEC is the circumscribed angle, but we know that's related to the central angle. So let's find the central angle first. So the central angle is equal in measure to its intercepted arc. So if this is 114 degrees, this is also 114 degrees. And then central angle plus circumscribed angle is 180 degrees. Okay, so that leaves 66 degrees. Oh, I guess I should have called this by the three-letter name, DEC. Okay, so for 16x, this arc over here, well, I don't have an angle that intercepts x only, but I see this 39 degrees intercepts this entire section. Okay, so the 44 and the x combined. Well, 39 as an inscribed angle times 2 means that together these two sections add up to 78. So if I take away the 44 degrees, that leaves 34 degrees for x. All right, what's y? Well, we've got a full circle here. We know every other measurement except for y, so we can just subtract everything else away. Okay, so 360 degrees for a full circle. Then you take away all the other arcs, and that would leave 150 degrees for y. Okay, so in order to get z, again, we would have to deal with this angle out here, which we don't know how to do, so we'll skip that. Okay, so lots of stuff here. AT and AZ are tangents, so we know that those form right angles. So F is 90 degrees. AZ means that J is also 90 degrees. All right, so let's see what else we have. Okay, so this 50 degrees, oh no, let's start here. So this 25 degrees is an inscribed angle, right? Its vertex is on the circle, and it intercepts this arc, which we're calling G. So we know the intercepted arc is double the inscribed angle, so 25 times 2 means that G is 50 degrees. Okay, well, G also gets intercepted by this central angle A, and we know central angles are equal in measure to their intercepted arcs. So A is 50 degrees. Okay, so now we can work with this 50, I suppose. So this 50 degrees inscribed angle intercepts this big section. So 50 times 2 means that this big section is 100, but we already know that this little portion is 50, so that leaves 50 more degrees for letter H. Okay, and then once we know that H is 50, then its inscribed angle is letter B, right? Angle B cuts off this angle, so central angles are equal to their intercepted arcs. Okay, so now looking at A, B, and C together, those three combine to a straight line of 180. So 50 plus 50 is 100, meaning there must be 80 degrees left over for C. Okay, so now that we know central angle C is 80 degrees, its intercepted arc is called M, and central angles are equal to their intercepted arcs, so M is also going to be 80 degrees. And again, using the fact that these three angles form a straight line, 50 plus 80 is 130, so that leaves 50 degrees left over for letter D. And letter D's intercepted arc is called N, so those are equal in measure. Okay, letter E is supplementary to the 50-degree angle, so what plus 50 is 180, that'd be 130. Okay, and lastly letter K. So K looks like this angle over here. Well, we've got a triangle, 80 plus 50 is 130, which means 50 more degrees over here. And then these three angles, the J, which is 90, plus 50 is 140, plus K equals 180. So 180 minus 140 means there's 40 degrees left over for K.